Hi, today I'm just going to be going over the CBA just so that you guys can have something to look at while you are doing your problems. I know it's been, 6 weeks since you've done some of this stuff, and so it's okay to be rusty, but it's important that you guys actually do try as well, just to make sure that we get this correct. So let's get started. First things first, I just want us to look at this right here. We have 6.2a, which is a TEKS. And it says, I classify rational numbers using a visual representation such as Venn diagrams to determine the relationships between sets and subsets of numbers. And so this should be pretty familiar to you. It's basically trying to figure out what number belongs in what category. I'm sorry for walking away, but if you feel like you're not very confident on this, if I were you, I would look at page number 9 in your notebook. Page 9, which says the real number system, will help you out. But if you do know what we're doing, then that's even better. We have -5. Because it's a negative and it's like a solid number, we know that this is an integer as well as a rational number. It's not a whole number, however, because it has a negative. Therefore, it's just rational and an integer. The next number we have is 23. I know it's rational, I know it's an integer, I know it's a whole number, and it's also a natural number. It's all of these things because it's at first, at its core, a natural number, which is a number that you can count on your fingers and it'll still be correct. This one a lot of students had trouble with. They see the negative and they immediately think, oh, it's an integer. However, 4/5 is actually a fraction. Because it's not a complete whole number, we can't consider it an integer. So integers are only solid numbers, like 0, 1, -1, 2, and -2. Because it's in between these numbers, we can't really consider it an integer. We have 3 2/10, which should be pretty straightforward. It should be a rational number because, again, it's not a whole complete number. And last but not least, we have 0, which should be a whole number. It's not a natural number because natural numbers do not include 0. So these are our 5 numbers, and this is where they belong in our little Venn diagram. Like I said, if you need help doing this, please refer to page 9. Okay, so this is about locating stuff on a number line. This is also pretty straightforward, especially because they're all positive. We shouldn't have too much trouble. We know that it's split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. And so I know that we can just split this up in tenths. We have 48 and 1/10, 48 and 2/10, 48 and 3/10, 48 and 4/10, 48 and 5/10, 48 and 6/10, 48 7/10, 48 and 8/10, and 48 and 9/10. Well, these are actually pretty straightforward. I know this one, 48 and 4/10 goes right here. 48 and a half, also known as 48 and 5/10, belongs right here. This one is a little bit more tricky because it's 9/100. But I know that 1/10 is going to be slightly greater than 9/10, which is why 48 and 9/100 would be right here, right next to 48 and 1/10. Last but not least, we have 48 and 3/5, which is also 48 and 6/10. Sorry about that. Which would be right here. We're trying to figure out which number would be the closest to 49, which is 48 and 3/5, or 48 and 6/10, whichever one you prefer. So this is pretty straightforward because it's positive. However, if you look at these, you're a little bit less cool because it's negatives and stuff. And so the first thing we should look at are all these improper fractions. I don't like them. We should change them into mixed numbers. If you don't remember how to do that, please refer to... Sorry, I'm trying to find it right now. Please refer to page 12. If you don't know how to refer, If you don't know how to convert from mixed or improper, please look at page 12. And it'd be more than happy to help you out, I'm sure. So if you refer to page 12, it should tell you to divide the numerator into the denominator and you'll get your answer. So let's look at point P. We have 24 divided by 3. 3 goes in 24 8 times, and so our answer should be -8 for point P. Point Q, same thing. You divide 9 by 2. You should get 4 5/10. And so you should get -4 5/10 as your point Q. Point R, if you do top in, bottom out, you should get 3 5/10, positive because there's a negative here. And lastly, if you do S, 15/3, you should just get plain +5. So that's how we change from a improper fraction to a mixed number, or just a decimal form. And now this is going to help me out because I can plot these a lot easier if they are in decimal form. So let's look at point P, -8. Well, that looks about right because it's 1, 2, 3, 4, 5, 6, 7, 8 away from 0. So P looks okay for me. But Q is -4.5. Let's look. -1, -2, -3, -4.5 would actually be right here. And so Q is not written in the correct spot. Let's look at R. We have 3.5, so that's 1, 2, 3.5. R is correct. And last but not least, we have 15/3, which is 5. 1, 2, 3, 4, 5. S is in the correct spot as well. So the only number that's incorrectly labeled is our -4 5/10, because Q is actually at -3 5/10, which is the wrong spot. All right. Now we're going to move on to the back of this page and look at the 4 students playing trumpet. Again, because I like decimals, the first thing I will do is change these to decimals. You should remember that 2/3 is a benchmark fraction. It's actually 6/10 repeating. We should have 1.5, which is 1 5/10. We should have 1/4, which, if you think about quarters, should be 25 cents. And lastly, you should have this one, which is 7 top in, bottom out. So 7 divided by 12. And then we need to do the math to figure out what our answer would be. So as I'm dividing, hopefully we got this. But you should have gotten something close to 1 583 thousandths with the 3 repeating. In case you guys are wondering where I got the ones from, all I did was I took my original fraction and split it up into the 1 and the 2/3. Even when we convert to decimal, the 1 will still say the 1. However, the 2/3 might change to 6/10, repeating. And so basically, I just split up our whole number and our fraction. I left my whole number alone, but I changed my fraction into a decimal. And then I just added them back together to just get this. I hope that made sense. If not, I'll be more than happy to explain it to you one more time when we're in class. So the first thing I notice here is that all these numbers are not really in, the same place value. We have some tenths, we have some hundreds, and we have some thousandths. And I want them to all be equal. So I'm going to put my placeholder 0 here. But for this one, my placeholder should be 6 repeating. And so now, finally, I can list my students in order from least to greatest. Please notice, I'm doing their names, not their practice times. So who studied the least? Ryan did, because 2 is the smallest number. Next we have Gus, because 5 and then 0 is smaller than 8. So next we have Jacob. And last we have Cole. And that's how we put these in order from least to greatest. If you guys wanted to do this in fraction form, it actually would have been slightly easier. I just want to show you how you could have done this if you wanted to make these into fractions. So we have Cole, which is 1 2/3. We have Gus, which is 1 1/2. We have Ryan, which is 1 1/4. And Jacob, which is 1 7/12. If you really were driven to do this as a fraction, you could have just looked for a common denominator. In this case, it would have been 12. And so you could have changed all your denominators to be out of 12. So 4 times something equals 12. Well, 4 times 3. What I do to the bottom, I have to do to the top. So it's 1 times 3. 3. Same thing with Gus. 2 times something equals 12. What I do to the bottom, I have to do to the top. What's 1 times 6? Lastly, one last time. 3 goes into 12 how many times? What you do to the bottom, you have to do to the top. So 4 times 2 is 8. And then from here, it's a lot easier to, convert our numbers. Order our numbers. And so we see Ryan is still practicing the least. Gus is the second to least. Jacob is the third to least. And Cole is the fourth to least. This is a perfectly viable way as well. If you like fractions and you enjoy finding the common denominator, if they're all in fraction form, it doesn't hurt to try. However, more often than not, you will have them as a mixed match, not just all fractions, but some fractions, some decimals, some percents. And so if you're in that kind of situation, it might just be more comfortable to change them all to decimal. Speaking of mixed matches, we have this, which are not very well. They're decimals, we have a little bit of fractions, and we want to change them all to be common. So how do we change from a percent to a decimal? If you have trouble converting from a percent to a decimal, please refer to page 6 and page 7 in your notebook. Page 6 and 7 will help you the most. But if you said divide by 100, you should be correct. So 8% divided by 100 is 8/100. 1/12, if you divide and do the math, you should have gotten 83 hundredths with the 3 repeating. 83 thousandths with the 3 repeating. 16% should be 16 hundredths. And then 1 out of 20 should just be 5 hundredths. I have all these decimals and they're not all in the same place value. So what I would do is I would order them by lining up my decimals and seeing, which ones go where. So the first number is 8 hundredths. And then I have 83 repeating thousandths. I have 16 hundredths, and then I have 5 hundredths. I'm going to add my placeholder zeros, and it's only from here that I can order them from greatest to least, because I have a clear idea on which one's the biggest one. Obviously, 16 hundredths, or 16%, is my largest number. After that, I have 83 thousandths repeating, with the 3 repeating, or 1/12. Then I have 8%, which is 8/10 repeating. 8/10. Just straight 8/10. I need to redo that. I'm sorry. Okay. The first number we have, which is the biggest, is 1600ths. Next, we have 1/12, which is the same thing as 83 thousandths with the 3 repeating. The next one we have is 8%, also known as 800ths. Then lastly, we have 500ths, or 1/20. This is the order from greatest to least. As you can see, because our numbers were lined up, we were able to see quickly and easily which one's the biggest one and which one's the smallest one. Now we're going to move to this one. It's basically talking about the equivalence of this. When we're dividing fractions, we have 3 rules. Same, change, and change. I should leave my numerator the same, change the division sign to a multiplication sign, and change 3/4 to the reciprocal, which is 4/3. Well, normally, I'd multiply, get my answer, and, I'd go on for there. But these answer choices don't ask me for the answer. They ask me for which one of these is equivalent to this. So I'm going to look for 8/9, which is not here, not here, and not here. Then I'm going to look for 4/3, not here, and not here. And so as long as you know how to same, change, or keep, change, flip, for those of you who learned it like that, as long as you know how to same, change, you should still get B as your answer. Now we have this one. This one is actually kind of tricky. A lot of students had trouble with this. When you have 4 and a letter next to each other, it basically means 4 times P. There are 2 ways you could have solved this problem. If you remembered that a proper fraction times a number is less than the original number, and then, an improper fraction times a number is greater than the original number. If you memorize this, then you didn't have to do any math. You could just say, okay, well, I'm looking for what's less than 4. So I'm looking for a proper fraction. And then you could have easily, pick C. However, we only went over that once in class. And even then, it wasn't very a big topic. And so if you didn't memorize it, it's perfectly fine. As long as you knew that you had to multiply, you could have just gone down every single one of these and multiplied by 4 to see which one has an answer less than 4. So 4 is equal to 4/1. So let's try to multiply this. 9 times 4 is 36. This looks a lot greater than 4, because 8 times 4 is 32. So know that it's like 4 and 4/8, which is, greater than 4. Well, then let's try 19 times 4. 19 times 4 should be 76. And if our denominator is 17, well, 17 times 4 is 68. And so I know immediately it's larger than 4, because 76 minus 68 is 8. This is still a number that is larger than 4. 7 times 4 is 28 over 8. Well, 8 goes into 28 about 1/8. 22, 68, 3 times, because 8 times 3 is 24. So as you can see, this one is less than 4. That looks like our answer. But just to be safe, let's do D, because come on, you have time. You should have 64 over 16. If you do 64 divided by 16, you should actually just get 4. Which 4 isn't really greater than 4, but it's not less than 4 either. And that's why C would be your answer. This is one of the trickier ones, but we got these questions from the STAR test. And so it's important that even if you don't know like one way to do it, you should still have a backup plan on how to solve the other questions as well. Finally, just some easy straight multiplication. If you don't remember how to multiply decimals, please remember. If you don't know how to multiply fractions, just please remember, just multiply straight across. This is on page 13 if you need help. But let's multiply straight across. 5 times 1, 5. 8 times 4, 32. Boom, easy. When you multiply decimals, this is going to be on page 14. But you just multiply by normal until you get the decimals. So the number is going to be kind of big, but I think we can do it. If you don't mind, do this in silence. That way I can make sure I'm doing it correctly. So I got 4. I got 15,904. And sure, you can think that's your answer, but we didn't count the numbers behind the decimal point. We have 1, 2, 3 numbers behind our decimal point, which means we have to move our decimal, the invisible decimal at the end of every number, 1, 2, 3 times. So you should have gotten 15 and 904 thousandths. Now we have dividing fractions. That's on page 13. The trick is to same, change, and change. I'm leaving this the same, which would be 5 over 8. I'm going to change my division into multiplication, and then I'm going to change my 1/4 into its reciprocal, which is 4 over 1. 5 times 4 is 20, and then 8 times 1 equals 8. If you simplify, it should be 10 over 4, or 2 1/2. That seems like a good stopping point. I'll post the next video probably tomorrow.